Okay, test. So for tutorial 1, any problem or any question that you face, any issue, so we can discuss. You can hear my voice, right? Please respond.
Sir.
Okay. No issue, on tutorial 1. It's easy, right? So I will discuss maybe 2 or 3 questions. And the rest of the question I will discuss with the group. Okay? Because I believe that you have done some of the question. So let's see. Start with the easiest one. Number 1. Number 1, the question is find the answer for below questions. Square wave with frequency of 847 Hertz goes through how many cycles in 2 minutes and 57 seconds? So you have to find how many cycles in 2 minutes and 57 seconds for the frequency of 847. Okay, it's a basic questions. So let me write here. Formula for frequency is F1 over T, right? For 1 cycle, one over T. For Fn cycle, there's n cycle equal to n over T. Okay. So by using the formula, frequency is 847. N is the question. T. The unit must be in seconds, so you have to convert 2 minutes 57 seconds to second. So 2 minutes is times 60, 120, 120 plus 57, 120 plus 57, 177. So N will be 7 times cycle. Okay. That will be for A. Any question, just type in the chat room, or you can interrupt. B. If omega equal to 240 radian per second, what are T and F? How many cycles occur in 27 seconds? How many cycles occur in 27 seconds? So the formula for omega, W or W, equal to 2 pi F. Right? So from here, you can find F equal to 2 pi. Omega is just now 240 over 2 pi. Okay, that will be F. T is 1 over F, right? You have from here F, you have from here F. The third one, N. We use this formula for N. F so F N cycle equal to N over T, right? You have F here. You have F from here. This one. And T, you have T from this one. Then you can get N. How many cycles? Okay. C. If 56,000 cycles occur in 3.5 seconds, what is omega then? If 56,000 cycles occur in 3.7, what is omega? Okay. So still, F equal to just now how many cycles per second, right? F, how many cycles per second? Definition of F is how many cycles per second. The unit is hertz. So 56,000 over 3.5 hertz. It's around 16. Is it 16? Yeah, 16. 16 kilohertz. So to get omega equal to 2 pi f. So 2 pi 16k. So you get how many radian per second? Okay. Number 1. That will be number 1. The easiest one. So let's go to the one in the middle. One in the middle. Question 10. Let's see number 5. Yeah, let's try number 5. 5 and 6 similar. So number 5, given these two waveform, V1 and V2, V1 8 sine omega t plus 45 degree, V2 40 sine omega t minus 80 degree. So A, sketch the above waveform with horizontal axis scaled in degree. Horizontal axis is the x-axis. X-axis scaled in degree. Okay. Sketch. So if you sketch the okay, this is so example. This is for example, this is 80. This is 40. 40. This is 80 minus 1. So for V1, because V1 is plus, so V1 is ahead by 45 degree. The maximum is 80. So if you sketch Okay, let me use different color. Maximum is minus 80. Okay, this is V1, for example. V1. V2. Let's use another color. V2. V2 amplitude maximum is 40. 40. And the degree is lagged by 80. By 80. So minimum is maximum is 40, minimum is minus 40 then. So the graph will look like this. Look like this. So this one is V2. Then we name the degree. So this one, some color. This one has 45-degree difference. 45 degree is from here. Okay. As for this one, has 80 degree. 8 degree difference. It's from here. Okay, so that's the A sketch of the waveform of V1 and V2. B sketch phases for V1 and V2 phases. So basically phases is XY. This one, for example. Okay. Okay, V1 degree is 45 plus 45. So V1, I use green. Yeah, green color. V1. V1. Tiger. La la la. V1. 45 degree. This is V1 equal to 84. Okay. Then V2, V2, the degree is minus 80. So it's a bit steep. Minus 80. This is 80. Amplitude is 40. V2. 40 volt. Okay. There is B. B. Okay, and there is the faces. If you have to sketch faces for V1 and V2, look at the degree first. If it's plus, so it's going up, the green one. If it's minus, must be below then, below the x-axis. Okay. And then what is the phase difference between V1 and V2? Phase different. Phase different. Okay, before that one, we go to D first because C is a bit length, so we go to D first. Determine which voltage leads and which lags. Which voltage leads and which one lags by how many degree. Okay. Just by looking at the waveform, this one, we can tell the green one is lead. The green one is V1. Lead by how many degree? Lead by 45 plus 80. So V1 lead V2 by 125 degree or vice versa. V2 lag V1 by 125 degree. Okay. Just by looking at the waveform sketch. Okay, now see phase difference between V1 and V2. Okay, have to delete this one first. Okay. Now, if you look at this one, this one, this one, we have to find both horizontal and vertical component of both voltage, either V1 or V2. Okay, and then we sum all together. So how many total horizontal component? How many is the vertical component? The total. Okay. Okay. Let's see now. We find the horizontal component first. Horizontal is the x-axis. Okay. X-axis. This one and this one. So if we project, for example, if we project V1, if we project V1 into x-axis, right, in here, in here, that will be V1, that will be 80, because the amplitude is 80, that will be 80 cos 45. What about V2? If we project V2 into x-axis, this one, that will be 40 cos 80. Okay. This one, if you use your calculator, you will get, right, 6. This one 6. If you add all together, you will get 63 to 5. Okay, so this is the total horizontal component. Okay, now we need to find the vertical one. So if we project V1 against y-axis here, right, and V2 against x-axis in here. So if we project V1 against x-axis, that will be a t sine 45, V2 V2, that will be 40 sine 80. Okay, this one is same because sine 40 equal to cos 40, cos 45. This one 39. Okay. Now this one we have to subtract. Why is it? Why we need to subtract? Because if you see in here, V1, it goes up, right? The projected V1. As for the projected V2, goes down. But why is it plus in here, in X, in horizontal component? Because both V1, both projected V1 and V2, this one, they are both in the same quadrant here. This one, same quadrant. Unless, for example, V1 is in here, then it will have to subtract. But in this case, both V1, both projected V1 and V2 are going the same direction. So we have to minus this. This is equal to 17. 7. Okay. This is total vertical. Okay. Now by using Pythagoras law, we can have V1 plus V2. What's the question this one? To the 6. 0.52, for example, plus 70.18. You will get 65.80. Okay. As the face, for the face, so if you draw the face different, this is the horizontal is 36.52, the vertical is 17.18. Okay. The phase difference is inverse tangent of 17 6 over 52. You will get around, check, tangent, okay, 15 point degree. This is the phase difference. Yeah, I don't see any question here, so proceed with the last questions. 5 done. Okay, number 8. Number 8. Oh, you want to number 10 or that's okay, similar. Number 8. Let's do number 10 then. 1, 5, 10. So you can check the rest of the question with another group. Number 10, what is the equation of 25 current sine having an RMS, so square value of 30 ampere? Okay. If you check the slide, RMS I, check the slide later. So I RMS was maximum. I maximum equal to I RMS so 0.7 S. If you check the slide later on, you will find that this is the value, the relation between RMS and maximum. Okay, so maximum is RMS is 30. Okay, so it's around 43. 43. Okay. Oh, general equation of current here. IT equal to IM sine omega t. Okay. Now we need to find IM, which is just we did just now, and need to find another one is the omega here. This one equal to 2 pi f. Right, so 2 pi frequency that's not given is 25. So it's around 50 times 3.14. Check. Pi is 3.14 times 50. It's around 157 radian per second. So just put the value inside here. I am is 42.43 sine omega is 157 t ampere. That's it. Okay. No question, eh? Don't see any question here. So let's do one more then. Let's do one more. Let's try number 8. Number 7. Number 8 is similar to number 10. Number 9. Yeah, let's try number 9. Starting current is given by expression IT 300 sine 157t plus pi over 3. So maximum value. Remember the general format is IT equal to IM maximum sine if there is a phase here. Okay, A maximum value. Maximum value is given already has straight direct question. Maximum value of current is 300. Frequency It's from this one, get equal to 2 pi f. So f equal to 2 pi 157, 2 pi 320. Check. 157 divided by pi divided by 2. It's around 25 hertz. Okay. Periodic T is 1 over F, so 1 over 25, right? 0.04 second. Okay. I think that's all. If you have no questions, you can check later the rest of the question with other group because I will discuss the other questions with the other group. Okay, guys, if you have no questions, I'll see you next time then. Okay, thank you.
Thank you, sir.
Thank you, sir.